Good morning my dear students and welcome to Big Data Analytics class. So, in this class we will be learning about MapReduce, that is called as our unit 2. So, these are our course outcomes which we have already discussed in our previous sessions. So, Big Data Analytics class has 4 COs, that is about preparing for data summarization, query and analysis. Course outcome 2 is about analyzing data modeling technique to large data sets, and course outcome 3 is about creating applications on big data analytics, and course outcome 4 is about building complete business data analytic solutions. So, in unit 2 we will be learning about these concepts, that is called as writing MapReduce programs, understanding Hadoop API for MapReduce framework, basic programs of Hadoop MapReduce. In that we will be learning about driver code, mapper code, reducer code, record readers, combiners and partitioners. So, these are the contents for the unit 2. So, in today's session we will be learning about these concepts, that is called what is MapReduce and what are the important advantages of MapReduce and where this MapReduce will be implemented. So, that we are going to learn in this today's session. So, what is a MapReduce is? MapReduce is nothing but it is a programming framework, which allows to perform distributed and parallel processing, where you are going to perform the parallel processing on large data sets. You are going to perform in a distributed environment, you are going to perform the parallel processing. So, that is what the MapReduce is. So, what is a MapReduce? A MapReduce is a programming framework which allows us to perform distributed and parallel processing on large data sets in a distributed environment. So, how the MapReduce will work is, the MapReduce will work in this fashion. So, the large data sets will be given as an input to the MapReduce, and to process this large data sets there will be n number of map phases, and these map phases are performed by using the map functions or map methods, and all together we call as a map tasks. After performing this job, the next phase comes, that is called as reducer, and reducer job is done by the reduce method, and we will be having a reduce tasks we call as, and ultimately the final output will be given. So, this diagram demonstrates that the map and reduce will take the large data as an input, and then the map phase comes first, then the reduce phase comes later, and the final output will be given by the reducer, which is called as a final output. So, in this fashion the MapReduce works. So, what is MapReduce is? The MapReduce basically consists of two distant tasks. It basically consists of two important tasks, that is called as map and reduce is one, where the map job is taken first, then the reducer job takes place later. So, the map takes the large inputs. After taking the large inputs, it processes, and then the output of the mapper phase is nothing but key value pairs, and that key value pairs, which is called as the intermediate output, will be given to the reducer phase. So that's what we have described here. As the MapReduce suggests, the reducer phase takes place after the mapper phase has been completed. That means, first of all, we are going to see the mapper phase is going to come first, and after that the reducer phase takes place. That means the first is done by the mapper and second is done by the reducer. So first is the map job, where block of data is read and processed to produce key value pairs, and these key value pairs are nothing but intermediate outputs. They are called as a intermediate outputs. And the output of a mapper, or map job, that is called as a key value pairs, will be as a input. It will be as a input for the reducer, and the reducer receives the key value pair from multiple map jobs. So there will be a multiple map jobs will be available. Then the reducer will do the aggregation job. The reducer will perform the aggregation job, and for the reducer it takes the intermediate key value pairs, and finally the output will be given by the reducer, and of course the output of the reducer will be also in the fashion of key value pairs. So I repeat it once again. So in the MapReduce phase, first the mapper comes into the picture, and the mapper takes the input as large data sets. Once it takes the large data sets, it processes it. After processing, it gives the key value pairs, and which is called as the intermediate output. And this key value intermediate output will be given to the reducer. Reducer performs the aggregation, and aggregation, after the aggregation also, reducer gives the final output in the form of a key value pair. Yeah, this is the diagrammatical presentation of the MapReduce. As I told you that the input taken by the map phase, this is my input, large amount of data sets are there. We have a map jobs are there, and the map jobs is performing the mapping process, and then there will be internal shuffling process is going to be done. During this shuffling processing, key value pairs will be generated, and this key value pairs will be given as the output by the mapper, and this key value pair will be the input for the reducer, and the reducer will also performs the aggregation here, and the final output is also in the form of a key value pair only. So this diagram demonstrates that the map takes the input as a large data sets, and it processes it. After processing it, it gives the key value pair as an intermediate output or intermediate code to the reducer, and reducer takes it as a input value, and the reducer will perform the aggregation, and then it gives the final output, and the final output is also in the form of a key value pair. So what are the important advantages of the MapReduce is, there are two important advantages of the MapReduce. What is the first advantage is, that is called the parallel processing is one of the important advantage of the MapReduce. So let us see this diagram. This diagram shows this. This diagram shows this. This is the traditional approach where all the data is stored at the master. You can see this. These are my blocks of the data, and all the slave nodes are approaching the master to get the data. All the slave nodes are approaching the master to get the data, and this is your traditional approach, which is a lot of time consuming, as well as movement of the algorithm is cheaper than the movement of the data. So it is more expensive. Whereas if you see the moving processing unit to the data, that is called the MapReduce approach, where in the slave nodes data are stored here. There is no data present in the master. The master only keeps the meta information of this data, Metadata is nothing but data about data, which node is storing what amount of data, what kind of data, whether the node is been given a read permission or not, that kind of information will be held by the master node as a name node. So, these slave nodes will be holding the data. So, I will not be moving this data. Wherever my data is there, that in that data I will be passing the algorithm. So, this shows that movement of the algorithm is simpler than the movement of the data. Whereas, if you see here in the traditional approach, we are trying to move the data, which is more costly, more time consuming, and there is a network problem issues also will be raising. Whereas, if you see here, there will not be such kind of problems, there will not be any costly affair will be there, because wherever data is there, I will be keeping my data there itself in the same node only, just I will be passing the algorithm, that is all, not more than that. So, it will be cost effective also. So, the next advantage of the MapReduce is data locality. What is a data locality is, as I said you that moving huge data to processing is costly and destroys the network performance. Processing takes time as the data is processed by single unit, which becomes a bottleneck. The master node can get overburdened and may fail. So, that is a major problem with the traditional approach, whereas in the MapReduce approach, you can see here all the data is available in the node, and to process the data on the node, I am passing the MapReduce logic. Similarly, here also this is another node where I am having a data on this node. Now, I am passing simply my MR logic, that is called the algorithm. The same thing is happening with the other nodes also. So, here there will not be any network problems also, there will not be any problem issues which will be occurred for movement of the data, because I am not moving the data. Wherever my data is there, my data will be available in the node, just I am passing the algorithm. So, in this fashion, we are getting a good advantage with the MapReduce, that is called as parallel processing and data locality. These are the two important advantages of the MapReduce. So, why we are using the MapReduce is, we are using the MapReduce because of its advantage. Then the two most important advantage of using the MapReduce is, that is called as taking processing to the data. So, I am not moving the data, So, wherever my data blocks are available, I am just keeping the data blocks there only. Just what I am doing is, I am moving the processing power, that is called as my algorithm, I am moving here, that is all, not more than that. So, that is the reason why I am making use of MapReduce. And processing data in a parallel fashion is also the reason why I am using the MapReduce. So, obviously the advantage of the data locality making me to make use of the MapReduce, the advantage of parallel processing making me to make use of MapReduce. So, these are the reasons why I am making use of MapReduce. So, where I can use the MapReduce? I can use the MapReduce at any location, there is no specific restrictions, but here are the few examples of where I can use the MapReduce. I can use the MapReduce at the weather for the weather forecasting. I can use the MapReduce for forecasting the weather. I can use the MapReduce for healthcare. I can use the MapReduce for oil and gas industry. So, let us take the example of weather forecasting. For example, just imagine that I am having a large data sets of the environment or the temperatures which I have collected for 2020, and I want to find out which day was the highest temperature and which day was the lowest temperature, which day had the highest humidity, which day has the less humidity, which day had the highest rainfall. All such kind of programming aspects I can do with the help of the MapReduce, with the help of the weather data sets which we have collected through the sensors. I can apply the MapReduce even in the healthcare mechanisms also. For example, as this COVID pandemic has generated large amount of big data with respect to the coronavirus, so I am having a large amount of data with respect to coronavirus. So, which patient is affected with the COVID-19, which patient is not affected with the COVID-19, all such analysis also I can perform, which comes under the healthcare analysis. Similarly, with the help of the CT scans also, I can perform the analysis which lungs are infected with the COVID-19 and which lungs are not infected with the COVID-19. So, all these things I can apply by using the MapReduce phenomena. Even I can apply the MapReduce phenomena by using for the oil and gas industries too. There are few more uses or where I can apply the MapReduce is, I can apply the MapReduce for the document clustering purpose also. Whenever I am having a clustering work, I can make use of MapReduce. Whenever I want to go for distributed sorting purpose, I can make use of MapReduce. I can make use of MapReduce for pattern based searching mechanisms also. Whenever I have a pattern based searching applications, I can apply the MapReduce. Even I can apply the MapReduce in the machine learning also, and Google is already making use of MapReduce to regenerate Google's index, Google index World Wide Web, through the World Wide Web. And I can make use of MapReduce for the multiple computing environments such as multi-cluster, I can use for multi-core and mobile environments. So, apart from the weather forecasting, apart from the healthcare, apart from the oil and gas industry, I can make use of MapReduce for the pattern based searching, for the machine learning, for the multiple computing environments such as multi-cluster, multi-core and mobile environments. In other areas also I can make use of map and reduce. Thank you for listening the class. So, in this today's class, we have covered about the map and reduce and its importance, its advantages, and in which areas, on what kind of applications the MapReduce can be implemented. In our next sessions, we will be seeing the practical demonstration of the map and reduce. Thank you for listening the class.